and welcome back to another episode of Science. In this episode, I want to teach you how to calculate acceleration and also how to calculate final speed. So let's get started. Firstly, what is acceleration? Acceleration is not only the change of speed, but how quickly that speed changes. For example, let's look at this diagram here. In the first second, this car increases its speed from 0 to 12 kilometers per hour, so plus 12 kilometers per hour. From the first to the second second, it adds on another 12 kilometers per hour, taking its total to 24. In the next second, plus another 12 to 36, plus another 12 to 48, plus another 12 to 60. So this car has accelerated to 60 kilometers per hour in 5 seconds. It does this by adding on 12 kilometers per hour every second. So this car's acceleration is 12 kilometers per hour every second. And that's how we would write it. 12 kilometers per hour every second. That's how fast it is increasing. Now, I've got a couple of cool videos for you to watch here. I definitely recommend them. This will show you how astronauts train in order to be shot up into space with a rocket. You experience a lot of G-forces when you're accelerating at such an extreme speed being shot up into space. And so this centrifuge is how astronauts train for that experience. This video shows the man who strapped himself to a rocket, and the rocket was on rails. He broke some world records on acceleration and deceleration. You should definitely watch this video, it's pretty cool. So load up the PowerPoint, click on these and enjoy. Okay, let's get started on our formulas. So average acceleration is change in speed divided by time. Or in other words, the final speed take away the initial speed divided by time. Now these are represented by letters A, V, U and T. So acceleration equals final speed, which is V, minus initial speed, which is U, divided by time, which is T. Using this formula, pause the video and see if you can calculate the answer to this question. A car speeds up to 56 kilometers an hour from rest in 7 seconds. Calculate its average acceleration. Express your answer in meters per second squared or meters per second per second. Pause the video here and have a go. Okay, assuming you've paused the video, I hope that you noticed that the units don't match to start with. So 56 kilometers per hour and 7 seconds don't match. What you need to do is convert this to meters per second. So if you remember the formula from the previous episode, and if you don't, re-watch that, retake your note. In order to go from kilometers per hour to meters per second, you need to divide it by 3.6. So I'll do that on my calculator now. 56 divided by 3.6, and you should do the same, equals, so this in meters per second is 15 point, we'll just round it up, 15.6 meters per second in 7 seconds. So now my units match. I can plug it into the equation and come up with an answer. So a car speeds up to 15 meters per second. That is the final speed. That's U. So if I put 15.6 here, take away my initial speed. Now the car's coming from a position of rest, which means 0. Divided by my time, which is 7 seconds here. So your calculation should be 15.6 divided by 7. 15.6 divided by 7 should give you an answer of 2 meters, about 2 meters per second squared. Now take careful note of this squared symbol. This squared symbol is telling you that the car is accelerating. Every second the car is gaining another 2 meters per second of speed. Right, so this 2 meters per second squared is an acceleration. If I write 2 meters per second here, that is a speed and this is an acceleration. This is purely just constant speed, and this one is telling you the car is getting faster by 2 meters per second every second. So this one is an acceleration. And we show acceleration by writing as meters per second squared or meters per second per second. Let's go forward. Let's have another practice. While traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the car's acceleration? A negative value indicates slowing down or deceleration. Pause the video here and have a go. Okay, assuming you've paused the video, let's punch these numbers into our equation here. While traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. So his final speed is 15 meters per second. So I can put 15 here. And the initial speed u was 24. And if I do that in my calculator, 15 take away 24 equals -9 divided by time, which was 12 seconds, and my units match, meters per second, seconds, so I can continue with my calculation. So -9 divided by 12 should give you -0.75 meters per second squared. The negative is indicating a deceleration. So you can write acceleration equals -0.75 meters per second squared, or you could write deceleration equals 0.75 meters per second squared without the negative symbol. So be careful what terminology you use. If you write deceleration, you can say it equals 0.75 meters per second squared. Because you've already written deceleration, so you don't need to include the negative. If you include the negative though, you should write down acceleration equals -0.75 meters per second squared, which indicates a negative acceleration, which means that it's getting slower. Okay, let's have a look at final speed now. The formula for final speed equals initial speed plus average acceleration multiplied by time taken, or V equals U plus AT, and you should do this part first. Teddy is jogging at a speed of 2 meters per second. He accelerates at a rate of 2 meters per second squared for 4 seconds. Okay, so all the units match. I can go ahead with my calculation. What is his final speed in meters per second? Pause the video here and have a go. Assuming you've paused the video, let's now plug the numbers into the equation and see what we get. So initial speed is 2 meters here. Accelerates at a rate of 2 meters, average acceleration here, multiplied by the time taken, 4. So we want to do this first. So 2 times 4 equals 8, plus the initial speed, which was 2 meters per second, plus the initial speed. So now I want to go 2 plus 8, and that will give me a final speed of 10 meters per second. 10 meters per second. Let's have another go. A train initially traveling at 18 kilometers per hour accelerates at a constant rate of 2 meters per second squared for 10 seconds. Calculate its final speed in kilometers per hour. Pause the video here and have a go. This one's a bit trickier. Assuming you've paused the video, let's have a go at this one. So the first thing I hope you notice is that the units don't match. I've got 18 kilometers an hour, meters per second, and seconds here. I need to make this one matching these two. So let's go ahead and do that. Let's change this to meters per second. If I go 18 divided by 3.6, that equals 5 meters per second. 5 meters per second. And now it matches my other units in here. So let's plug these numbers into the equation. My initial speed here is 5 plus my acceleration, which was 2, multiplied by my time, which was 10. And I want to do this first. And plus symbol here. So 2 times 10 equals 20, plus your 5 here. That will give you a final speed of 25 meters per second. 25 meters per second. But remember, the question is asking you to give your answer in kilometers per hour. So in order to go from this 25 meters per second, you would multiply it by 3.6. And if you multiply 25 by 3.6, that gives you 90 kilometers per hour. From here, you should have a practice of your own with the acceleration goodness booklet that I've given you, and keep working on your education perfect. Thank you for watching this episode of Science, and I'll see you next time in class.